We can see here that if I apply the matrix A, 0, 0, B to the matrix XY, then I'll get A times X plus 0 times Y, which would just be AX. And then I'll get 0 times X plus B times Y, which would just be BY. So what this matrix does to the coordinate XY is it turns it into the coordinate AX, BY. So what's happening is the X coordinate is being multiplied by A and the Y coordinate is being multiplied by B. So in effect what that's doing is it's just stretching out the X coordinates by a factor of A, and it's stretching the Y coordinate out by a factor of B. So what we can say is generally that this matrix here represents a transformation that is a stretch of scale factor A in the X direction and also a stretch of scale factor B in the Y direction. If it so happens that actually A and B are equal, if they are the same thing, if these numbers are the same, then it is a stretch in the X and Y direction of the same factor, in which case we would just call it an enlargement like we had at GCSE. So this matrix here represents an enlargement scale factor 4. Right, let's have a look at an example. So here I have a triangle T and I want to transform it by this matrix here. So I can see that this matrix represents a stretch of 2 in the of scale factor 2 in the X direction and scale factor 3 in the Y direction. And I can do that by applying that matrix to each of the coordinates of the vertices of this triangle. So this is the coordinate 1, 1. So if I apply this matrix to the coordinate 1, 1, 2 times 1 plus 0 times 1 is 2. 0 times 1 plus 3 times 1 is 3. So this coordinate here gets transformed to the coordinate 2, 3. So I could mark on that coordinate 2, 3 to be here. Next, this coordinate here is the coordinate 4, 1. So if I apply this matrix to that coordinate, 2 times 4 plus 0 times 1 is 8. 0 times 4 plus 3 times 1 is 3. So this coordinate here gets transformed to the coordinate 8, 3, which is there. And then finally this coordinate here, that gets transformed to the point 2, 9, which is there. So I get my new triangle here, which I'm going to label up as being T dash to represent the image of T. And as we can see, hopefully, that this triangle here has been stretched out by a scale factor of 2 in the X direction and by a scale factor of 3 in the Y direction. Now, if we were to consider the area of both of these triangles, so the area of triangle T here to begin with, so simple triangle, half base times height, so half of the base, which is 3, times the height, which is 2, so that's just 3. So the area of triangle T is 3. Similarly for T dash, if I do a half base times height for that, the base here is 6, the height here is 6, so a half 6 times 6, that's just going to be 18. So the area of triangle T here is 3, the area of triangle T is T dash is 18. The area scale factor is 6. This gets multiplied by 6 to get 18. Now let's consider the determinant of this matrix. Let's think about that. Let's work out the determinant of this matrix. The determinant is 2 times 3 minus 0 times 0, which I can see is just going to be 6. So notice that the determinant of the matrix actually gives you the area scale factor. And that's always going to be the case. The determinant of a matrix is equal to the area scale factor. You don't need to know the proof for that, you just need to know how to use it. So let's do another example where we actually use that fact. So here we go, I've got a matrix here that transforms triangle R to triangle S. I'm told that the area of triangle S is 72 units squared, and I want to know what's the area of triangle R. So I know that the determinant of this matrix gives me my area scale factor. So if I work out the determinant of this by doing 2 times 3, which is 6, take away minus 2 times minus 1, so minus 2 times minus 1 is 2, so 6 take away 2 is 4. So that tells me that the area scale factor is 4. So to get the area of the new shape S, I would multiply the area of the old shape R by 4. So the area of R times 4 would give me the area of S. Therefore, if the area of S is 72, then the area of R is going to be 72 divided by 4, which is 18. So key things from this video is recognising that this represents a stretch in the x direction by scale factor A and a stretch in the y direction by scale factor B, and the fact that the determinant of a matrix will give you the area scale factor.